Okay, this tutorial demonstration emulates what we did yesterday in the networking lab. What we did yesterday in the networking lab is we took two routers, we connected them together on serial connections, okay, and right now I've made this the 50 network in between these two routers. So this router is 50.1 and this router is 50.2. So we connected two routers together serially. Then we connected clients to a switch to the router on Ethernet for LANs. And over here I've got the 192.168.1 network. This is 1.100, host 1.100. And then over here we've got a 172.16 network. And this host is 172.16.0.100. And the router over here is 172.16.0.1, and the router over here is 192.168.0.1. So the first available host for the router gateways on these two LANs. All right. So effectively, between these two routers, we have three networks: 1, 2, 3, and you can see them circled there, right? So now, what I want to demonstrate is if I click on the router and I go to command line interface. So there's the router. There's no configuration on the router. But what we can do is we can type enable, and then we can do a show IP route to look at the routing table. And that's what I want to talk about today, is the routing table and also dynamic versus static routing. You can see in the routing table that we have two connected routes. You can tell they're connected because they've got a C in front of them. And we can see that this router, router 1 on the left-hand side, is connected to the 1 network and the 50 network, directly connected. On the fast Ethernet is the 1. On the serial interface is the 50, 192.168.50 network, right? So this router has two connected routes in its routing table. And this router, if we go to command line interface, type enable, also has two connected routes on its routing table, right? The two connected routes are the routes that are connected on its interfaces. So if I was to draw a picture of this, all right, if I was to draw a picture of this, this router knows about these two networks, okay? This router knows about these two networks. And let's see here, deselect, and we'll click on that. And this router knows about these two networks, right? Okay, so what that means is if we try to ping from 192.168.1.100 to 172.16.0.100, it's going to fail. So we'll demonstrate that. Command prompt, ping to 172.16.0.100, and you can see destination host unreachable. And the reply is from 1.1. So essentially what's happening is this router is saying, hey, I don't know where the 172.16 network is, so I'm going to drop those packets, right? So now there's two solutions to this. To let this router have a route, we have to let this router, router 1, R1, know about the 172.16 network, and we have to let R2 know about the 192.168.1 network. So it goes both ways. We need a route going this way from left to right, and we need a route on this router going from right to left. And we can set those statically, or we could use a dynamic routing protocol like RIP. RIP version 1 is the first routing protocol you learn in the CCNA curriculum. It's the oldest routing protocol, I believe, or one of the oldest. It's an oldie but a goodie. And what the dynamic routing protocol is built for is if we enable RIP on these two routers, then the routers will exchange routing table information with each other. And so R2 will tell about its two networks to R1, and R1 will tell about its two routes and tell R2. And so eventually they will learn dynamically about the extra routes. So let's set that up really quickly. So we'll go in here, and what I'll do is, I'm just hitting enter here, configure terminal, right? And I'll type router RIP, and that turns on RIP. And notice I'm in config-router mode now. And then what I have to do is I have to tell the router about the networks that I want to participate in RIP. So I'll tell it about network 192.168.1.0. Tell it about that network. And then I'll tell it about the 192.168.50.0 network. Now, these two networks are the networks that are on my connected interfaces for R1. This is R1 that we're talking about here, right? And then I'll type end. So now we have RIP configured. If we do a show run command, you'll see that now in the running configuration, it says router RIP, and then it has the two networks that are participating, the 1 and the 50, right? And this is the 1 and this is the 50, the two connected networks. Now for this router, we do the same thing for its two networks. So I'll just hit return a bunch of times, conf t, which is short for configure terminal, and then I'll say router space RIP, and I'll tell about its two networks, network 192.168.50.0, and up arrow, we're going to say 172.16.0.0. Okay, and then hit end. All right. Now, both routers are exchanging routing table information, exchanging RIP updates out of its interfaces, and shortly we should see that the routing tables change. So we'll go back to router 1 here, and we'll do an up arrow till we get to show IP route, and we'll look at the routing table, and you can see now in its routing table that router R1 knows about its two connected networks, right? But it also has an R route here for this is a RIP route that it learned about dynamically. R stands for RIP. You can see here the R means RIP. You can see it knows about the 172.16 network. The administrative distance is 120 for RIP, and then the hop count is 1. It's 1 hop away via the next hop router's interface, which is 50.2. All right, and if we go to this router, we'll do the same thing. Show IP route, and you can see that this router also has an R route that it learned about. It learned about the 192.168.1 network automatically. 120 is the administrative distance for RIP. 1 is the metric or hop count in this case, so 1 hop away via the next hop router's interface, which is 50.1. And you can also we can stretch this out, and you can see going out of its own interface, serial 2 is its own interface, right? So now we can ping. So if we open up this and we try to ping the host now, it should work. And we'll send the ping. Timed out, but nope, there it is, it's working. It just had to do some ARP broadcasting to learn the MAC addresses, but you can see here that we got some replies. If we do it again, we get some replies. We can see that we can now ping across the network.